So first and foremost, what is a radian? A radian is a way to measure how much you rotate, just like degrees, guys. So it's just like, how do you measure distance? With feet, with meters, centimeters? It's the same thing. So one revolution, you guys already told me this. One revolution, and this is just a review real quick, is how many degrees? Yeah, you guys already told me that. So what do you think one revolution is in radians? Do we know? All right, here we go. Here's where it comes from. What is circumference of a circle?
Oh, the 2.
The 2. And the...
Oh, 2 pi r.
2 pi r. Where r stands for radius, correct?
Yes.
So one revolution in radians is 2 pi radians. You don't have to write the word radians. So now you know that one revolution in radians is just 2 pi. It is unitless. You just say 2 pi. You don't put a degree symbol. So if you want to write the word radians, that is perfectly fine. So there it is. So how do you measure one rotation? You can say it with degrees, or you can say it with radians. If you say it with degrees, you put a degree symbol. If you do not put a degree symbol, then you're telling me radians. Cool? Or not cool? Cool. Super cool. All right, so here we go. Let me label these axes with radians, 0. And then this is a quarter of a quarter of 2 pi. So that's going to be pi over 2. There's going to be pi, because that's half of a revolution. So half of 2 pi is pi. There's going to be 3 pi over 2. And then 1 full revolution is 2 pi. Every 90 degrees is pi over 2, guys. So I've been telling this to every class. The distance between that x-axis and the y-axis is pi over 2. That's another pi over 2. That's another pi over 2. So you guys can see where that 3 pi over 2 came from, right? Pi over 2 plus pi over 2 plus pi over 2. That's just 3 pi over 2, see? And if I add another pi over 2, 3 pi over 2 plus pi over 2, that's 4 pi over 2, which is also 2 pi. How do we feel? I have no more tissues, just brown paper. Sorry, miss. Yeah, go for it. Same thing, guys. If you go clockwise, here's 0. If you go clockwise, that's going to be a negative pi over 2, a negative pi, a negative 3 pi over 2, and if you've done a whole revolution, negative 2 pi. How do we feel so far? Nothing crazy, right? Okay, so we've made the connection that 2 pi radians is equivalent to 360 degrees. Are we okay so far? So I don't want to use 2 pi radians equals 360. I mean, we can to do conversions, but here's what we're going to use. I'm going to take half of 360. So 180 degrees is equivalent to how many radians? Yeah, someone said it, I think. What did you say? Say it loud and proud. Yeah, pi radians. This is what we're going to use to convert. And notice, we didn't use Google or anything. You found that conversion on your own. Right? Right. So this is what we're going to use, guys. So check it out. Let's go to the question. Oh, well, I guess first let's talk about coterminal angles. Let's start doing let's do a basic angle. So I'm going to say, let's see, what do I say first? I'm going to say pi over 3. No, pi over 6. Let's change it up. Pi over 6 is in quadrant 1. Travis, how do you know that? I know it's in quadrant 1 because this is pi over 2 up here. 0, pi, 3 pi over 2, and finally 2 pi. So pi over 6 means 1/6 of pi. And 1/6 of pi is definitely a lot less than half a pi. So it's probably closer to the x-axis than the y-axis. So I have something like this. That distance here in blue is pi over 6. Can you give me another coterminal to pi over 6? Well, yeah, I have this definition here. And that definition tells me that I can add 2 pi to it. And no one is freaking out because 2 pi just means 1 revolution. So if I add 2 pi to pi over 6, I will get a coterminal angle. So I'm going to take that pi over 6. I'm going to add 2 pi. Chavez, I don't know how to add 2 pi. Yeah, you do. You put a 6 in the bottom. You turn the top to a 12. 12 divided by 6 is 2 pi. Well, 12 divided by 6 is 2. And there's still a pi there. Does that make sense? I just did common denominator, guys. Just multiply by 6 over 6. If, you know. Cool? Okay. 12 plus 1, 13. So 13 pi over 6. 13 pi over 6 is coterminal. Chavez, how does that angle look like? Let me show you. That angle looks like... Let me get green here. That angle looks like this. I'm going to color this in 13 so we can color code it. It looks like this. That in green is 13 pi over 6. And it's coterminal. Notice that it creates the same ray. Very cool, right? Cool. All right, check it out. Let's go to the problem that we have not done. So scroll, scroll, scroll. And we get to here. Example 3. And we're going to go slow, guys. Don't worry. Oh, yeah. It's always hard after lunch, but that's why I ordered 2 coffees today. It is cold, and it sucks that it's cold, but that's fine. All right, here we go. Convert the following radians to degrees. They're telling you they're radians. So what do we say? How many radians in a degree, or how many degrees in a radian? Yeah, you can say 360, but there's another one. What did we say? 180 degrees in pi radians. That's what we're going to use. 180 degrees in pi radians. So I'm going to write pi over 3. This is a radian at the moment. If I want to get degrees, I'm going to multiply this sucker by 180 over pi. Yeah, perfect. The pi's cancel out. 3 goes into 18 6 times, so this must be 60. So now we have a general rule. I know you guys like little notes here, so I'm going to go to the right-hand side, and I'm going to put the general rule that we did. So I'm going to write, to convert a radian to degrees, comma, take your radian and multiply by what? 180 over pi. Perfecto. Try not to be a robot. Try really, really, really hard not to be a robot. We derived this. You guys told me the conversion. So if you were to Google would just tell you multiply by this, and then you would not know why. You're just doing it. But now, look, we did the concept of why. So you guys know. Critical thinking, guys. You guys are smart. Let's get those ACT scores super high. Do these come out on the SAT? Very basic ones. Very basic ones. Hopefully, when you get these questions, please get them right. Whenever you take the SAT, please tell me, oh, I saw that unit circle question and I got it right. All right, here we go. Ready? Which one do they want? 2 pi over 3. 2 pi over 3 times 180 over pi. Do I need a calculator for this? I don't think so. Pi's cancel out. I'm still going to go 3 goes into 18. 3 goes into 18 6 times. 6 times 2 is 12. Add the 0, 120 degrees. Or if you notice, pi over 3, 2 pi over 3. So pi over 3 times 2 gives you 2 pi over 3. So you can take that 60 and times 2, 120. Whatever, it doesn't matter. Patterns, there's patterns everywhere. Let's go to the next one, 4 pi over 3. If you want to go, well, 2 pi over 3 is 120. And 4 pi over 3 is just times 2 pi over 3 times 2. So I guess you could also do that, 120 times 2. But I'm going to go ahead and multiply it again by 180 over pi. 3 goes into 18 6 times. 6 times 4 is 24, so 240 degrees. How do we feel, guys? Awesome. So let's go to the next one. 5 pi over 3 times 180 over pi. Let's see, what's that? 300? 6 times 5? 30? And then the last one. 11 pi over 6 times 180 over pi. 6 goes into 18 3 times. 11 times 3. So 330. How do you feel? Okay. Example 4. The SAT level math subject exam is going away, which is kind of sad because I think this is an exam that we can do very, very, very well on. The level 2 one is, we just need to study for that one, but the level 1 one is one that you can just kill it, like just destroy it. But it's unfortunate that it's going away. That's fine. I took this question from a SAT level subject exam. Not an actual test, right, because that's impossible, but like a test prep book. I don't remember which one. I should have noted it in here. My bad. But one of the questions was this. And they let you use a calculator. So this would be a question where you have a calculator. Notice that 2.5 does not have a degree symbol. Plus, they literally tell you it's a radian. And it does not have a pi. So there's no pi on this. 2.5. I'm going to multiply that sucker by 180 over pi. This time the pi does not cancel out. You need a calculator unless you know, well, I guess you can probably estimate it, but yeah, you need a calculator. So take your calculator, and here I am taking my calculator. Don't worry, guys, we'll get to some really exciting stuff right now. And 2.5 times 180 over pi. So 2.5 times 180 over pi. There it is. And I said nearest tenth. So we're going to write 143.2 degrees. 143.2, and then put the degree symbol. Are we feeling okay? Okay. I tried to. Thank you, Miss Thomas.
It was great. We just it was iconic. I just it caught me off guard.
Y'all are funny. What's up? Here's what I've noticed, and that makes you guys a little different from previous classes. Please don't take this the wrong way. I'm not trying to. No, I promise I'm not. Please don't take this the wrong way. So you know how our first exams were pretty not very good, and in previous classes in the past, I'd pass out the exams and they were be kind of sad oh. But you guys, here's what I've noticed as a whole. Maybe not you guys specifically, but you guys, I pass out the exam, and you guys are like, oh, look what I got. What'd you get? And instead of oh man, you guys are like, oh, hey, this is not bad actually. This is not bad actually. I mean, I was expecting worse. I was expecting a lot worse. It's not bad. I'm okay with this. So that's. And in previous classes, previous groups, they'd be like, oh. But not you guys. You guys were like, not bad, not bad. And don't take that the wrong way. But that's just what I've observed. So. I think I got that on point. Did I get your class on point? So, I mean, every group is different. So that means that at least you guys see, the bright side of things, we can all laugh about it. Oh, yeah, okay. We'll get back to being awesome. Well, I mean, you guys are already awesome, but, all right. Here we go. All right, so example 5. So it says sketch these angles, and it's the same angles that we just did, guys. It's the same angles. So try really hard not to convert to degrees. Let's try to work with radians. Cool? So it says sketch these angles in standard position. That just means show me where it looks. Show me the ray. Show me the ray. I kind of want it to show me the money, or this is a way, or like movie quotes, right? This is a way. And calculate the measure of each reference angle. Okay, so they want me to show the ray, or the segment, or whatever you want to call it, and they want you to show the reference angle. So let's see. This one, pi over 3, so I'm going to draw a grid. And right now we're not good yet, so we're going to write 0, pi over 2, pi, 3 pi over 2, and 2 pi on my axis, just so we can get better at it. And then I say pi over 3. That's the same thing as saying 1/3 pi. What quadrant am I going to be in? 1, 2, 3, or 4? 1. I think we did this one earlier. Oh, no, we didn't. We did pi over 6. So pi over 3 is probably closer to the y-axis than the x. Yeah. But it's okay. It doesn't have to be perfect. And it's this distance that's pi over 3. And I did say ray, so there's my ray. But if you want to make a segment, that's fine. No big deal. We're not going to argue here about, cool or not cool. And that's it. And they also want, so there it is. That's my standard position. And they want my reference angle. Well, I'm in quadrant 1, so the same rules apply. The reference angle for this one is just pi over 3. Done. That's it. So on that one, if you land on quadrant 1, or they give you an angle that's already in quadrant 1, you can just leave it alone. That's your reference angle. All right, let's go to the next one. So here's my grid again. And 0, pi over 2, pi, 3 pi over 2, 2 pi. 2/3 pi. What quadrant? Quadrant 2. Probably like right there, because this is a whole pi right over here. So it's probably like right there somewhere.
Wouldn't it be closer to the
2 pi.
Because it's like 67%, which is technically like closer.
Yeah, 60. Okay, so if you think about 67%, the 100% is this.
Yeah.
So that looks like 67%.
Yeah.
That looks like, you know what I mean? If you're thinking of it, I know how you were thinking. I know what you were saying. So yeah, it makes sense. So it's somewhere there. It doesn't have to be perfect. It's okay if you were to draw it closer to the x-axis than y. I'm not going to put a frown or anything like that. We're just trying to get better at it. As long as we know we're in quadrant 2. If you wanted to convert this to degrees, you can. I think we did it earlier. All right. So next, what do I want is my, there it is. That's it. What do I want? I want a reference angle. Reference angle is this in blue. 1/3 pi, pi over 3. How'd you do that? Yeah, I heard someone say add and then subtract. You can do both. You can do both. 2 pi over 3 plus pi over 3 would have given you a whole pi. See, 2/3 plus 1/3. And that's where I'm at. Or you can do the rules that we did last time. So what's the rule? So you can go, let's see, what can you do? QR is equal to, instead of 180 minus angle, you can do pi minus angle, or pi minus 2 pi over 3. And notice, yeah, see, it works. 3 pi over 3 minus 2 pi over 3 is your 1/3 pi. See? Pi over 3. Yes.
Can you go over that last part again?
Yes. If you want to figure out your reference angle, you see this black line here, or this that I'm doing right here? That is pi. If you want to figure out the blue one, you can just go pi minus the red one, and that will give us the blue one. Do you see that?
Yeah.
So this right here is a pi minus the red one, and it gives us that blue reference angle. And I probably should color code it. Let me see if I can do that. Pi over 3, black, and oh, sure that's blue. Pi over 3, and this is red. There, now it's color coded. What's up? Yeah, ask. Hey guys. Yes, I put 3 over 3 because I need to have a common denominator to subtract. But if you can see it, like a whole minus 2/3 is 1/3. If you can visually see it, that's fine. But I did that for everyone else that needs to have a common denominator. All right, here we go. Any other questions on this, guys? Let's go to the next one. 4 pi over 3. 0, pi over 2, pi, 3 pi over 2, 2 pi. So 4 pi over 3 is slightly larger than pi. So I'm going to be in what quadrant? 3. So here I am in quadrant 3. Theta equals 4 pi over 3. And take a guess, what do you think this in blue is? Yeah, it's a reference angle. Pi over 3. Well, because I chose all of them. Because I chose all of them over 3s. It'll be different for the last one. Next time I'll have a more variety. So next notes I'll update it. 0, pi over 2, pi, 3 pi over 2, 2 pi. Here we go, guys. I am going to graph 11 pi over 6. Focus on that 11 over 6. I am pi over 6 away from 2 pi. Do you guys see that?
So it's like right, like 4 quadrant, but like almost what you just
In quadrant 4, pretty close to the x-axis. Something like right there. Theta equals 11 pi over 6. Travis, I don't see how that's 2 pi. 11 pi over 6 plus 1 pi over 6 will give you 12 pi over 6, and 12 divided by 6 is 2. You guys see that?
Yes.
So what's my reference angle? Lozano, what's my reference angle? Lozano.
I have no idea. I was just trying to process what you were saying.
Oh, man.
Is it
Yeah. Tell me why.
because to get 2 pi from 11 pi over 6, you add 1/6.
Yeah. So she's just completing the pizza here. I'm almost, see how 1 revolution is 2 pi? I already covered 11 pi over 6. So if I add another pi over 6 to it, it'll be 2 pi. There, I'll write it out. 11 pi over 6 plus pi over 6 would give me 12 pi over 6. And 12 pi over 6 is 2 pi. See that? What's up, miss? You could do, because I'm in quadrant 4, let me put the rules over here. Quadrant 3, quadrant 4. If you're in quadrant 4, you could always do, what's 1 revolution? 2 pi minus the angle they gave me, 11 pi over 6. Notice I'm going to do common denominator, so I'm going to put 12 over 6 like that. And I get pi over 6. There's so many different ways to get that reference angle. As long as you understand the concept, there's no way you can get it wrong. Look at quadrant 3. How do I get the reference angle in quadrant 3?
You subtract the value of the angle
Minus
pi.
perfect. It's the same rule if it were in degrees, but in degrees, we would go angle minus 180. But now we're in radians, so 4 pi over 3 minus pi, common denominator, is a 3, so I put 3 over 3, and check it out. Pi over 3. Yay or nay? Yeah. All right, let's see. Where are we at now? Last example here. It says, convert the following angles from degrees to radians. Express your answer in simplest forms. Okay, this time we're going from degrees to radians. Before we went from radians to degrees. So what's the game plan if we're going to do the opposite, or radians, degrees to radians?
Can I say what I would do?
Yeah.
Okay, so for A, I would do 495 like over 360. That's like the total amount.
I'm listening.
Oh, okay. And then like have it equal to x over 2. Oh, pi. Not bad.
Let me see if I can get that. Yeah, you can do that. You can do that.
Coolio.
If going from degrees to radians, but let's.
That's right.
It is right,
Oh.
but let's make it easier for you. Instead of doing 360 and 2 pi, let's use pi and 180.
Oh my god, yeah.
Right?
Period.
So if going from degrees to radians, comma, take your degree and multiply by, before we did pi over 180, so now we're going to do 180 over pi. Oh, the other way around. Pi over 180. Sorry, guys. Pi over 180. The other one was 180 over pi. There you go. Now we got it right. Yes.
Pi over 180
Because we're converting to radians. So we need the radian on the top and the degree on the bottom. You know what I mean? Perfect. It's similar to unit analysis, but it's not as heavy. All right, so check it out. So I'm going to take this 495, and I'm going to multiply by pi over 180, and you're going to get 495 pi over 180. And don't leave it like that. Let's reduce it. So how do you reduce it? I'm just going to put the 495 over 180 in the calculator here. 495 over 180. And I'm going to tell my calculator to give me a fraction. Math, fraction, enter. Did I not do it right? 495. Let me clear it everything. How come you guys didn't tell me that I put 498? 495 over 180. And then math, fraction, enter. 11 pi over 4. 11 pi over 4. And that's it. 720. Do you guys watch the X Games? Do you guys ever watch like skaters and they like do tricks?
Yeah.
So what does it mean when they do 720?
Half of it's like
Yeah, it's how many revolutions?
2.
2. So if you just use logic, 720 is 2 revs, and we said that 1 rev was 2 pi. So then 720 must be 4 pi. And that's just using logic. So let's see if our math is correct. 720, and it is, times pi over 180. And that is 720 pi over 180. And then 720 over 180 will give you 4. And if you don't believe me, here we go. 720 divided by 180. And you, in fact, do get 4. Cool? All right. Let's go to the next one, guys. 60 degrees. So I'm going to go 60 times pi over 180. I don't think you need a calculator for this one. 6 goes into 18 how many times? 3. So that means 60 goes into 183 times. This is just pi over 3. Done. Let's go to letter D up there. So 165 times pi over 180. So 165 pi over 180. I'm going to tell my calculator to 165 over 180 and then reduce it. So 165 over 1, oh, look at that, I put an extra. 165 divided by 180, enter. Math, fraction, enter. 11 pi over 12. 195. Let's see, 195 pi over 180. And that's going to give us, I feel like that's going to be 13 pi over 12 or something. 195 over 180. Math. Yeah, 13 pi over 12. Using symmetry, right? 15 degrees, 165 is 15 degrees away from 180. So 180 plus 15 gives you 195. So keep the denominator 12, add 1 to the... I'll stop. Last one. You can grab a water, miss, if you want. There's one water right there. If you want, whoever was copying, there's a water. Multiply by pi over 180. I don't think we need a calculator for that one. I think we can do this one without it. Let's see. Greatest common factor, 12 and 18. 6. 6 goes into 12, how many times? Twice? 2 pi. 6 goes into 18. So 2 pi over 3. How do we feel? Yeah, I think we're gold, guys. So let's go to the activity. And let's do all the odd ones together.
Yeah. That means
Activity. Open. All right, here we go. We're going to do all the odds. It says sketch the angle in standard precision, mark the reference angle, and find its measure. So that just means find the reference angle. Mark the reference angle and then find the angle. Ready, guys? Number 1, pi over 5. What quadrant am I in? 1. So I exaggerated the first quadrant. Pi over 5 is probably closer to the x-axis and y-axis, but no big deal. That's pi over 5. And that's also my reference. So theta r is also pi over 5. If you're in quadrant 1, that's going to be it. And you're done. That's it. What do you guys think? All right. Let's look at number 3. Oh, did you have a question? Yeah, ask. What's up? Oh, yeah. Remember, we label our quadrant 0, or our axis, sorry. 0, pi over 2, pi, 3 pi over 2, 2 pi. And 1/5 of pi is smaller than half a pi, because 1/5 is like 0.2 pi, and then half a pi is like 0.5 of pi. So that's how I know I'm in quadrant 1. So let's look at number 3. This one says 6 pi over 15. So focus on the 6 over 15. 6 over 15, is that smaller than half a pi or bigger than half a pi? Smaller. Because if it was 6 over 12, that's half. So if the denominator gets bigger, like 6 over 15, that's less than half. So I'm somewhere closer to the y-axis. Doesn't have to be perfect. Something like that. That is 6 pi over 15. And my reference is also 6 pi over 15. What do you guys think so far? All right. Check it out. Help me out with this one, Miss Thomas. 39 pi over 20. Don't worry, Miss. Look, we'll all do it together. What quadrant do you think I'm in? It's okay, guys. Look. It's okay. We're rookies. No, look. Check it out. Look. Check it out. 39 over 20. I am one number away, one integer away from being 2. 40 divided by 20 is 2, right? So I'm really close to what? I'm really close to 2 pi. So what quadrant am I in? The 4th. So here we go. 4th quadrant. Pretty close to the x-axis. This one's the closest one so far. We don't know. Well, I guess you can turn it into degrees. But yeah, it's pretty close. There it is. I'm going to say that right there is 39 pi over 20. How close am I to the x-axis? 1/20th of pi. So I'm going to write pi over 20. You can say 1/20th pi, but I like to put the pi in the numerator. So there it is. There's my reference angle. Do you see how we did it? Yeah, pi over 20. Uh-oh, we have a negative one. Relax. This is going to be in quadrant 4 because 5 over 21 is smaller than a half. So there is quadrant 4, 0, negative pi over 2, negative pi, negative 3 pi over 2, in case you want to label. And this one's probably closer to the x-axis. Doesn't have to be perfect. Probably right there, like so. That right there, this angle in that direction is a negative 5 pi over 21. And I'll slow down. Is my reference angle ever negative? No. So I'm not going to say negative 5 pi over 21. I'm going to say what? Perfect. Remember, it's always with respect to the horizontal. So since I measured from the horizontal to that as negative 5 pi over 21, my reference has to be 5 pi over 21. Yes? Okay. You okay? Yeah. No, ask. It's all good. Perfect. It's that distance away from 0. Negative 25 over 17. Ooh, Chavez, I don't know that one. All right. I think you're right, actually. No, I think that's quadrant 2. 0, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Let me see. 25, 17. 17, 7, 14, 7, 14, 20. It's, okay, yeah. I'm going to help you. It's so close. It's so close. So negative 3/2 pi is the same thing as negative 1.5 pi. Do you guys agree? Yeah. All right. 25 over 17 is actually really close to 1.5. But we don't know if it passes it or if it's below. So take your calculator and just go, let me clear this. I'm just going to go 25 over 17 because I just care about what that is. Like what that is as a decimal. 1.47. So that means you're going to go clockwise. Are you going to pass negative 1.5 pi? No, it's going to be just to the left of it because we're going clockwise. So it's going to be like this, guys. Right there. Just to the left. Probably closer than that, but just to the left. So there it is. That right there in burnt orange is negative 25 pi over 17. Let me change the color to University of Houston red. I want the reference. I don't know how to do that, Chavez. Yeah, you do. Now it's just playing with numbers, right? This is pi. This distance in burnt orange, the magnitude is 25 pi over 17. So I can just go 25 pi over 17 minus pi. Let's see. Chavez, I don't know how to do that. Yeah, you do. 17 over 17. What's the difference between 25 and 17? So this is 8 pi over 17, and that's your reference. Eight pi over 17 theta r. How do we feel, guys? Okay. The radians I think can be kind of tricky because you never used them before, but now we are. All right. Usually everyone is, pretty good with the degrees. So now everyone's going to be like, all right. So look at number 11. Negative 295 degrees. So we draw a little grid. That's going to be in actually quadrant 1. Here's 0. Here's negative 90, negative 180, negative 270, and then finally negative 360. So it probably helps to label the axis first. Negative 295, you beat 270 a little bit, so you go right there. So that right there in red is negative 295 degrees. So my reference angle, I almost did a whole revolution. You almost did a whole revolution. How many degrees were you away? You see how we did it, guys? Because one revolution is 360. So the distance between 300 and 360 is 60, and then add another 5 to get to 295. Cool or not cool? All right, check it out. 98 degrees. What quadrant? Second quadrant. 98 degrees is just slightly bigger than 90. So there it is. That's 98 degrees. What's my reference angle? Is it 88, 82? Yeah. 180 minus 98. Do you see how we did it, guys? All right, negative 154. So let's do a grid real quick. 0, negative 90, negative 180. And I guess we could stop there, but... So negative 154, what quadrant? 3, yeah. That's negative 154. And then my reference, 54, 64, 74, 26 degrees. Do you remember how to do the big ones, 5481? Take your calculator, 5481 divided by 360. You can do what Lozano does, 15 times 360, whatever that is. Or I'm going to subtract the 15. And there you go, times 360. I got 81 degrees. So I'm in quadrant 1. And that's both the regular, that's both your coterminal and your reference. All right, guys, is it okay if we leave you here? All right. If you can finish it tonight, I would greatly appreciate it, or today. I would like the physical copy, but if you can't, turn it in on Canvas.